Okay, everyone. So I think I made an Einstein-Rosenberg bridge this time, but it took time dilation or time displacement and dilation to fix a point in time where you can go to two places at once and be the same age. But the problem with this is that you go to a black hole or a sun. And I can show you in a minute, but it's really complicated stuff if you don't already have the first thing that I said. So if you can't find me on 3 subscribers, I'll try to see if I can hook it up on 2 subscribers, but I don't know if I'll have the same explanation. Alright, so here we go. This is the equation. ERBA plus momentum congruent to wavelength times acceleration. Now you do momentum and congruentize that to that part. Now plus space and time conjugative to, or I think it's derivative. It should be derivative. Derivative to Newtonian time. Force congruent to time squared plus area times volume congruent to mass. And this is the only time that you can see what happens, because right here is a sun and right here would be a black hole. And they can interchange whenever they want to. What I figured out with ERBA was the fact that it's this one right here. So I don't know if you can figure this out any other way, but I would be wrong if I was putting this math together the way I did. But I have a space-time paradox right in the second row in the bracket. So the first one is pi. It's pi. Right here. That's pi. And then space-time paradox, I congruent to time squared. And some weird stuff happens when time dilation comes into effect. But I also made up inertia, which is right here. I guess it's what they wanted to see or something, but I actually can't remember which one I had put down. It was definitely the second one. This one right here. It's this one. And then I wrote inertia at the bottom, so nobody thought I was cheating. Minus wavelength. Alright, I was trying to make up parts of gravity to use, but I didn't use gravity. And so that's ERBA. ERBB is probably the first one of these ones. This one up here. Volume times mass congruent to kinetics. Plus force minus area times variant. Phi derivative to phi plus radius squared times pi h bar squared negative h bar squared with I congruent to space-time Newtonian congruent to x2. And then a acceleration congruent to wavelength. Momentum times time squared, I think. Mass times time displacement. E to the limit of x. Yeah, this is B. This is ERBB. So this is the third equation of a quadruple equation or a triple equation. So from what my knowledge is that this is ERBC, or I could call it ER or ERC, because I think I labeled the other one ERBP for Plotsky. I'm not sure what I named it, but I can label this what it is. And the second one, so it goes like this. The second, then top, then that one. And something is spinning simultaneously with the thing that's spinning the way it is already. So really you just need something that's going in the right rate of speed and it has the right time, or gravitationally has the right time, to take either a supernova or a star's last bits of its pieces and put it into a black hole. And I think the black hole would win, but if a star has enough energy far away, it might just pass by it. So here I have volume congruent to mass at the bottom and force congruent to time squared. So I think that's right. Alright, I think I'm good. Good job. Good job. I hope you guys like my information I'm trying to show you guys. I want to get voted for a Nobel Prize for one of these things. But if you don't want to vote for me, good luck. Try and find your own way home. I'm gonna kick some people out of my car. I'm going crazy, people. I live in a tiny room. That wasn't beer, that was an energy drink, because I have nothing better to do. And, yeah, check it out. I might have more things for you to see. Alright. Deuces.